Hi there, I'm Anowen Joy Emphasis Rabasho. I have a degree in mathematics from University of San Carlos, Cebu, Philippines. So here's the requested circle, and to provide additional context, I decided to share to you this video. Alright, so how is this circle being produced? So I'm using GeoGebra, so let's have a circle. And then we are going to draw intersecting chords. So we have chord CD, and then we have chord EF. So these two intersecting chords intersect at point G. Next, what are intercepts? So intercepts are the line segments produced from the intersection of two chords. So what are the intercepts in this illustration? So we have intercept CG of chord CD. We have intercept GD of chord CD, and we also have intercept EG of chord EF, and we have intercept GF of chord EF. So we have 4 intercepts. What is the theory that we need to prove? So the theory, there's a theory that states when two chords intersect within a circle, the product of the intercepts are equal. So this is the equation that we are going to prove. CG times GD is equal to EG and GF. And I need help in proving this equation using sine rule. To give additional context, I'm going to prove this theorem using a relevant theorem. Angles of the same arc or sector are equal. So step 1, we are going to connect EC and DF. Right? So we now have 2 triangles. So we have triangle CEG and triangle GDF. So we are going to show triangle similarity. How? First, we are going to show that corresponding angles are equal. How? We are going to first identify the corresponding angles. Angle CEG or angle E corresponds with angle D or angle GDF. So we are going to show that angle CEG or CEF is equal to CDF. Again, we angle CEF corresponds with angle CDF, or angle E corresponds with angle D. Take note and observe that the non-vertex points of angle E and angle D are C and F. So angle E and angle D have common set of non-vertex points C and F. And these non-vertex points of angle E and angle D are the endpoints of the arc CF. So we can say that angle E and angle D share the same arc CF, which form the sector CGF. So we can then use the theorem that angles from the same arc in the same segment are equal. Right, so we have a GeoGebra build to illustrate that further. So again, we have shown that angle E and angle D are equal because angle E and angle D are angles in the same arc, in the same sector. So let's validate congruency using GeoGebra by measuring. So we are going to measure angle E. It's 71.2. Then let's measure angle D. It's also 71.2. Now, the next pair of corresponding angles are angle C and angle F. Observe that angle C, or what we call as ECD, and angle F, we call it DFE. So now let's observe further that angle ECD, or angle C, has non-vertex endpoints ED. And then angle F, or angle DFE, also have points E and D as the non-vertex points. So we have, or we can see here that angles C and F share the same set of non-vertex points. And because of that, we can say that angle C and angle F share the same arc. Again, angle C and angle F share the same arc ED, which forms the sector EGD. And we all know that angles of the same arc in the same segment are equal. So we can then say that angle C and angle F are equal because angle C and angle F are in the same arc ED of the same sector EGD. So let's now validate further the congruence by measuring. So angle C is 54.3, and then angle F is 54.3 also. Okay, then next, the third pair of corresponding angles, we have EGC, angle EGC, and angle DGF. So these two are corresponding angles. And what can you say about the two angles? Yes, there are vertical angles. And we all know that vertical angles are congruent. Okay, so we have a GeoGebra build to illustrate that further. Okay, then let's use GeoGebra to show validity by measuring these two angles. So the measure of EGC is 54.5, and the measure of DGF is also 54.5. So we have shown and proven that the corresponding angles of these two triangles are congruent. So we can say that these two triangles are similar. Now, we are going to show the proven similarity of triangle ECG and triangle GDF to state the equality of ratios of the corresponding sides. So first, let's state the relevant note. When two triangles are similar, the ratios of the lengths of their corresponding sides are equal. We can find that note in this website here. Now we are going to identify the corresponding sides. So by inspection, we can say that side EG corresponds with side GD. And then side CG corresponds with side GF. Now let's use GeoGebra, okay, to show validity of such congruence. Alright, so let's measure the distances of the intercepts. So the distance of CG is 4.3, the distance of GD is 4.1, the distance of EG is 3.7, and the distance of GF is 4.8. The distance of EC is 3.7, and the distance of DF is 4.1. Again, intercept EG corresponds with intercept GD because these two line segments are not the shortest nor the longest. Okay, and then let's move. Okay, and then side CG corresponds with side GF because these two line segments are the longest in their corresponding triangles. Okay. Now we are going to describe the equality of the relevant ratios. So we are going to make use of the side length in the first triangle, okay, the triangle at the left in the numerator, and then the side lengths at triangle 2 to be in the denominator. Okay, so we have this equation then. EG divided by GD, because EG corresponds with GD. So we divide EG by GD. The ratio is equal to the quotient when we divide CG by GF. Again, CG corresponds with GF. Okay, so we compare the two side lengths by dividing. So CG divided by GF, okay, is equal to EG divided by GD. Now we are going to use GeoGebra Algebra 2 to show validity of that equation. Okay, so we have algebra tool here, and then we say distance EG divided by distance GD, that's 0.9. And then we have distance CG divided by distance GD, okay, GF I mean, distance GF is also 0.9. Okay, so this equality is correct. And then we're going to make use of this equality to derive the equality of the theorem that we are proving. So we have EG. So let me write that down. Okay, so this is the equation that we now have. So we are going to cross multiply. Okay, so we can now say that EG times GF, okay, is equal to GD times GF times CG. Okay, So therefore, I conclude that the product of the intercept produced from two intersecting chords are equal